In project 2, you're going to be building circuits and you're going to be working with the Arduino Uno to do physical computing projects. So at this point, everybody, I'm assuming, has looked at the basic introduction to electricity and circuits, which is on Teams. If you haven't, it would be a good idea to watch that one before we get into building circuits. So the first thing I'm going to do is just introduce you to some of the things that are in your kit which you may have not used before. So this is the Arduino Uno. This is the microcontroller that, it's a basic microcontroller that most people in design schools learn how to program. It's easy to use. It's been around for about 10, 12 years, something like that. Okay, so think of a microcontroller as, it's like a mini computer. And then we're going to build circuits. You're going to be building circuits, and I'm assuming nobody's ever built a circuit with a breadboard before. You may have done this in high school, I have no idea. But I'm starting at an introductory level where I'm assuming nobody knows how to do any of this stuff. So if you know this stuff, it's a review. You build a circuit on one of these things, which is called a breadboard. And they come in different sizes and colors, and different components fit into them. So it's like a little test environment for building circuits. So to build a circuit, you should know by now that you need a power source. So the electricity is going to run through the breadboard and it's going to power the component. So for example, if you want an LED to light up, get it in focus, you need some electricity going through it. You need a small voltage. Okay, so we're going to run power through the breadboard, and what's the power source going to be? So in your kits, you've got options. The power source that we're using is direct current, and we're using really small voltages. You cannot hurt yourself doing this work. You can't even feel the amount of electricity. So voltage, if you remember what a volt is, it's a unit of electricity. In your kit, you should have one of these. This is a 12-volt wall plug. Okay, so a wall plug, this outputs 12 volts of direct current. So 12 volts of direct current cannot hurt you. You plug it into the wall. And the wall plug is basically what that thing is doing. We call it a brick usually. The brick is taking 120 volts from the wall, converting it to 12 volts direct current. The voltage coming out of the wall is alternating current. So I'm assuming everybody knows, don't stick your finger into a wall plug because you'll electrocute yourself. But once that 120 volts is converted into 12 volts of a direct electricity, it's no longer going to hurt you. You can use it and you can be safe using it. So if you wanted to take the 12-volt wall plug and plug it into the Arduino, you could have a power source for your Arduino, and the Arduino can take up to 12 volts of power. So that's one way you could power the Arduino. If you wanted to take the 12 volts and run it through the breadboard and power the breadboard, you'd need a component that would take a plug here and plug in there. I don't have one right now. I don't think you have them in your kits. So let's say that we were going to power up the Arduino first. That's one way we could do it. The other way you can do it is from your computer. So everybody should have in your kit, you should have this plug, which is a USB plug, and the connector there, it's the same connector that goes into a printer, and it plugs into the Arduino, and then this side is USB. And because I'm on a Mac, I need a converter. I need to go from USB to USB-C because my MacBook Pro only has USB-C. So when I plug it into my computer, the green light goes on the Arduino, and the Arduino is powered up. So there's power source, okay? Now the Arduino can also output power from these pins. So I'll get to that in a second. So most of the time, the easiest way to power up a circuit is plug in your Arduino, and then I'll show you how to take the 5 volts to the breadboard. Another way that you can power up an Arduino is if you have a 9-volt battery. I think in your kit you should have one of these battery adapters. And it just snaps on like that. And it plugs in like this. And because my battery's dead, it's not lighting up. But if I had a fresh 9-volt battery, I could power the Arduino that way. So these are all the different power sources that you can find and use for an Arduino. So if you look at the Arduino, it's got pins. And when the Arduino is fired up, you can output power, and I'm waiting for the auto, there it is, autofocus, 5 volts, 3.3 volts will power, you can take the power out of the Arduino through those pins. So that's how we get power from an Arduino to a breadboard. And you'll also notice that we've got 2 ground pins. GND means ground. So those are the first pins we're going to look at on the Arduino. So let's power up the Arduino. Okay, so you can see the green light went on. So now the Arduino is powered up. And it's powered up because I plugged in my USB cable, and my USB cable is plugged into my laptop. So that's where the voltage is coming from, my laptop. So USB, the standard for USB is 5 volts. So I plug the USB cable in and 5 volts comes out of the device. So here's my Arduino, here's my USB cord, which is plugged into my laptop. And if I plug it in, I power up my Arduino. And I just showed you that we've got 5 volts or 3.3 volts that we can pull from the Arduino to the breadboard. And you're probably wondering, how do you do that? Well, I'm just going to stick a wire, which is red for voltage, from the Arduino into the breadboard, and then I'm going to stick a black wire into GND, which is ground on the Arduino, and it goes into the breadboard on the blue side. So the way the breadboard works, right now I've got 5 volts of power running through all of the pins on that red rail. So you can see a plus sign and a minus sign. The plus sign is the voltage, 5 volts running down that red rail, and then ground is blue, and it's running down the red rail here. So once I plug it in, and it's always a good idea to wire up everything and then plug it in. So now when I plug it in, I've got 5 volts and ground running on my breadboard. So now I can build a circuit on the breadboard because I know I've got power and ground. The wire that I used here is, this is called 22 AWG wire, or it's called hookup wire. It goes by a number of names. You're going to have to learn to cut the wire properly. So for example, if I wanted to cut a piece, using the tools that you have, which I'm assuming you've got one of these cutters, I'm not 100% sure what's in your kit. So if I'm showing you things that are different than what you've got in your kit, we can take it up in class. But if you look at, assuming you do have one of these kind of wire strippers, the part here will cut the wire, okay? So it's just, you cut the wire off. But to strip the wire, we've got the red plastic coating on the wire, and the trick is to put it in like this. See if I can get the focus to go. Come on, autofocus, work. Okay, autofocus is having a hard time working. Now, you squeeze it very gently and you pull the plastic wire off. So I've exposed the metal, and then the metal can go into the breadboard. It can go into a pin on the Arduino, etc. So that is called wire stripping, and there's a tutorial, a PDF tutorial about how to do that. And in that PDF tutorial is a bit old. It has a different type of a stripper. Okay, so I'm just very gently squeezing the plastic. The trick is you want to squeeze enough to take the plastic off, but you don't want to cut the wire, because if that wire breaks off in your Arduino, then it creates a big problem. Now you'd have a wire stuck in the pin on the Arduino and it won't work basically. Okay, so this is the most common way of wiring up a circuit with a breadboard, is just hook up wire. Here's another way we can work with electricity and breadboards. These are called header pins. So the header pins can go into the pins on the Arduino, into the pins on the breadboard. And the way that you would cut one of these would be, you'd use the cutting part of your tool, and you just cut one of these off. And then if I stick it into the breadboard here, it's going to have 5 volts of electricity running through it. And then the way you would get the electricity to another component would be use one of these. This is an alligator clip. So the alligator clip can clip onto a header pin, it can clip onto a wire, it can clip onto anything. So I put a couple of header pins in the Arduino with pulling 5 volts and the ground, and all I need to do is hook them up. So the black wire is going to the ground pin, and the red wire is going to 5 volts. And I have to be really careful. If those two touch each other, then it'll short out. Okay? And then I've got them running on the rails on the breadboard. So same thing, I've got ground and power running through the rails on the breadboard. So that would be a different way to set up. You do have to be careful though that the alligator pins on the Arduino, if it moves around a lot, it can turn it on and off. Okay, so you have to be careful. So to test that this is actually working, I could use a multimeter. I'm not going to go into a lot of details about how to work with a multimeter now. We'll do that at some point later in the project. But anyway, I've got it set here to read voltage, to read direct current voltage. And I'm just doing this to show you that it's actually working. Because if I had wired it up differently, it wouldn't work. And these are called probes, and if I put the probes onto the black one onto the ground wire, and you can see that we're getting 5.08 volts. So that is 5 volts. So I know it's all working. So the next thing you want to do is light up an LED. Because if you can light up an LED, then you know that your circuit is going to work. So LEDs look like this. They have 2 metal posts. One is long and one is short. And the long pin is positive. So if you were wiring this up, you would have 5 volts running through a red wire, and it would connect to the positive post, the long post on the LED. And if you had a ground wire or an alligator clip or whatever, it's going to connect to the short post on the LED. make the LED power up, it actually takes less than 5 volts. So if you run 5 volts through that LED, you're going to burn it out. And so we have to add a 100 ohm resistor to the circuit to make the LED light up, and LEDs will last forever. They'll last for like a decade if you don't overpower them. So the size of the resistor is 100 ohms. Let me see if the autofocus will get onto it. Okay, the autofocus isn't focusing on the resistor. Let me see if I can do it manually. Oh, okay. So 100 ohm resistor. In your kit, you're going to have a set of resistors. They kind of look like this. The label is going to have to be, you're going to have to read the label in your kit, 100 ohms. And if you're in a position where you really have to figure it out, again, you could measure from the multimeter, you can measure 100 ohms. 98.7 is close enough to 100 ohms that it's going to work perfectly. And the setting I had on the multimeter was, you can see that symbol for ohms, and I've got it set to 200. And that means, this is the way multimeters work. It's going to be an accurate reading up to 200 ohms. So the range of measurement, if it's set to 200 and you test it and you get 100, then you're positive that you have the right one. Because again, like I can't get a focus on the stripes, but you've got colored stripes on the resistors. There is a method of looking at the colored stripes on the resistor to know what the size of the resistance is, the ohms, okay? So for the first circuit you're going to build with an LED, you want 100 ohms. So the best way is to keep your packages with the label. When it says 100R or 100 ohms or something like that, you know you're going to have 100 ohms. If it says 100K, that's 100,000 ohms. K means 1,000. That's not going to be the right size. So I'm going to put the long pin into number 30 on the breadboard, and that means the short pin will go to number 31 or number 29, whatever. Don't worry about the numbers. The LED just pops right in there. Now to make the resistor go in, to fit in there, I'm going to put the resistor on the ground wire. The resistor, technically, it can work on either the power or the ground. So I'm sticking a resistor in here. And then the other side of the resistor I'm going to put here. And it should look something like that. I know it's hard to see because the LED is clear, but okay. So back to our breadboard. I explained earlier that the red rail sends electricity all down this line, so that all of these pins have electricity running through them and ground. Okay? Now, on the breadboard, it runs the other way. Everything runs this way. So if I plug a wire from here to pin 35, it means that electricity is going to be running on any of those pins. So the breadboard is like a grid of power and ground. So to make our LED work, I'm going to bend that up so you can see it a bit more. Remember that I stuck the long pin, which is the power side of the LED, into pin 30, row 30, and if I stick that into the red rail, I've got power running through it, and the ground post and the resistor are on the same one, and then the other side of the resistor is here, and I'm going to stick that into the ground rail, and the LED goes on. So on off. If I pull the power, the LED opens the circuit and it turns off. Same thing, if I pull the power on the ground, the circuit opens. If I push the ground wire in there, the circuit's on, and then that LED means my circuit works. I've got 5 volts coming from the Arduino. I've got a 100 ohm resistor to pull down the voltage running through the LED, which takes a very low voltage, and that's it. So that's your first circuit you're going to build. So the next thing you'd want to do if you have an LED set up on a circuit like that is to build a switch so that you can turn it on and off. So I'm going to show you like one way to do this, and I'm not sure exactly how many switches you have in your kit, but I just pulled one that I'm pretty sure you do have. This is a tact switch where you press the button down, it goes on, goes off. So all you need to do to think of what a switch is, the switch doesn't take power and ground. The switch is just one wire cut, disconnected, so when the wire touches, the circuit is closed, the light goes on. When the wire disconnects, the light goes off because the circuit is open. That's all we're going to do. So if I replace this one ground wire with 2 ground wires, it demonstrates what the switch is doing. All that's happening is the wires touch, the light goes on. And that's all that the mechanical switch is doing, right? Nothing more fancy than that. Press the button, light goes on. So it's a spring-loaded button. It's called a tact switch. Now, the problem is we don't have any soldering equipment here. So you can see that all I did was I wrapped the wire around the button, and technically it should be soldered. And this is a problem because you don't have soldering equipment. You don't have access to soldering equipment. But at this point, you might want to put a blob of hot glue there to hold the wire on. And to get the wire on, to bend it, you use these pliers. So anytime you want to bend wire, the pliers become a handy tool for doing that. So remember that these are the pliers that will bend the wire, these are the wire cutters that will cut the wire. And this will strip the wire. And it's going to take a bit of practice stripping the wire, because if you cut into the metal too much, the metal is going to snap off, and if it snaps off in the breadboard or in the Arduino, then you can't use that pin. So if you snapped off a wire in the pin of the Arduino, the 5 volt power voltage pin out, then it becomes a problem because it becomes almost impossible to use it. Okay, so now, whatever type of switch you have, I would start with a simple one like this. Make some switches for your LED.